So we go to the BOSCO download page, and in this case I will download the 1.2 alpha release. Since it had some bug fixes, you can use the production one if you prefer. I will enter my email. And start the download. This will give me a URL that I can use to download the BOSCO installer. And then I'll be running the BOSCO installer. Sorry, I had already a previous BOSCO installation on this account. So this is installed BOSCO. And now going back to the So after downloading, I'll choose the environment and start BOSCO. So then I will be adding a cluster. In this case, I'll use an account that I have in a local cluster here. Enter my password, and now BOSCO it's installing in this remote cluster. The next step will be testing this cluster, and so far these steps are very similar to what Derek did in its BOSCO demo. While it's testing, I'm checking if there is any question. You can, I think all of you should be able either to speak or to enter a comment in the chat. So BOSCO is still installing. And now BOSCO is ready to run on the cluster, and I can run a test job. So now while the test is running, let's see the second part where I will be downloading and installing SkeletonKey. SkeletonKey, it's a script that has been developed by Suchandra and helps to use Parrot and Chirp to be able to access data directories or CVMFS. So I'll be here. The test is still running. Okay, the job is still idle. So in the meantime, I'll be installing I'll be installing SkeletonKey. So I'm downloaded the installer script. I'll make a bin directory. And now I'm installing SkeletonKey.
Question: how much of Parrot and
not much. The script is covering most of the Parrot and Chirp stuff on the back for you. So you need basically just to start the Chirp server and then follow the instruction to add a specific configuration to say which directory you are accessing. But you don't need to know all the commands or the internals. So now I added my path, and I'm exporting the path. So now there is a little bit of Chirp setup, but this is guided here. This one will be covered in the next version by the script. I have to create a link to the Chirp executable. At the moment I've added it to the tutorial, but in the future will be covered by the script. And now I'm making some directories that I will access from my job to have input and output. So I'm making them in TMP. And I'm creating a directory with my username under TMP. And under that directory, I'll create a data and output directory. So now I created this directory, TMP. Now I go back to my home directory. Now, in order to be able to access this directory with Parrot is used when I launch the job with the SkeletonKey. I need to start the Chirp server to export them. So this is a Chirp command that I need to know. And that's all as far as the commands of Chirp that you need to know. Now I'm ready to test, to set up the binary and test the SkeletonKey. So as I said before, I have a published HTML directory that it's exported by a local web server on this host. And I'm copying the Parrot tar file. And now I'm making it visible. Now, the next step, is to create ini file that I'll be running a test to verify my SkeletonKey installation, and this in this init file, there is a specific syntax for SkeletonKey. You can find more information about SkeletonKey in the links that I provided at the beginning of the tutorial. So for now, basically, I need to know where to download Parrot and which application to run. So I'll be making a test. SkeletonKey test directory. I go into that directory, and and I edit SkeletonKey test ini file. So this has to be the URL where I make Parrot available. So in my case, I have this is my home directory. I'll make it a little bit bigger. This is my home directory that's exported in the server where I'm running, and you can see the file that I copied in your directory in the public HTML. So here is the URL, and I'll be running bnose name as executable for the test. Going back here. Now I can run SkeletonKey on that script. SkeletonKey is creating a job script.sh that is basically a wrapper for your job that's running Parrot to access all the directory that you specified in the ini file, and will run your job with that data access. So I can simply run it, and this is downloading the Parrot, creating temporary directory in TMP, and running whatever I told him to run within that sandbox. Now this is SkeletonKey, and now let's use both together and use SkeletonKey to submit our job. So I installed R on the OASIS CVMFS server, but at the moment, so OASIS, it's the OSG application software installation service. That's a CVMFS server that's available for multiple VOs to install application that can be accessed from OSG sites, or not only made available through CVMFS. I previously installed their 2 installation of R, but that's something that I'll have to review. There are some problems with that installation currently with the executable. So for this example, I'd be actually using an installation that it's on the UC3 CVMFS repository. Anyway, the process is very similar. Now I'm creating a new job where I will be accessing both CVMFS and the data directory, and running the R script. So I'm making a temporary directory where I'll be writing the scripts. Now in that directory, I'll have the script that I'll be executing. And I'll be calling this script myapp.sh. This is just a name that I give them in the ini file. So if you want to use a different name, feel free to do that. Here I specify basically the commands, assuming that CVMFS is available in /CVMFS and the name of the repository. And I use the scripts like if that were a local directory. So I'm adding to the library path the library dir of R, and then I'm running the R script with the R file and the data file. And the chirp mount is the output directory that I defined before in the temp directory. Now here is a simple R script that I have in the example. And I call it test.r. And this doing a simple brick transformation on the raster file that I give as input. Any R script that you like to run would do. So now I'm making sure that the my app it's executable. And now I'm actually copying here also the data file. I will make it also available in my HTML directory. So you can download the same file if you want. So if you check the sandbox directory that I will use for the execution, you will see that there is the myapp executable, the R script, and the data file. Now I'm starting this sandbox. And I'll be copying it in my public HTML directory. And making it readable so that the browser can access it. At this point, I have to, I need to have it available also the key for the CVMFS repository that I'm using. So in the configuration that you can see here for the job wrapper, beside the application and the directories like I had in the first example, now in Parrot, now I have also this CVMFS section where I'm specifying the CVMFS repositories that I'm using. And specifically, I'll be using, in this case, the UC3 repository. So I'm editing another ini file. Now the public key for the user3 CVFS is available online, and here reporting the URL, so you can directly access it from there. If you want to be sure, you can copy it from the web page and make it available in your public HTML directory if you want to have your local copy. And CVFS, in order to run, in order to access the repository, you need to use HTTP proxy. If you have a local one at your institution, that's the recommended one, because the closer this is to your cluster, the faster will be the transfer for the file with the less network traffic. In this case, I'm using the one of OSG ITB. If you don't have any other at your site available for this test, you can use that one as well. It will be not the most performant one, but especially if you are far from Chicago, but will work for the test. So the host is the itbware.uchicago.edu. And here I'm adding again the public key for the repository. So for the, here in the example, you find also the information for the OASIS repository, and we can add it to the file anyway. So, and here you will see the public key for OASIS, and I made it available also on the web. In this case, I have two repositories. They will be both mounted and available for the jobs that I'm running. Then other changes that I need to make here, it's the root directory that I have, TMP Marco. I used that directory, I created that one in TMP before. It's the one that I exported before running the chirp command. And here I need to correct again the URL where I make available Parrot and my job, the sandbox that I target. So this is here. If I refresh this directory now, you can see that this is also a job. Okay, now I edited my configuration file, and I'm ready to create the wrapper script. So the SkeletonKey script will create another file, and if I do, sorry, ls There's some confusion, but there is a JavaScript.sh. It has been just created. I can, to test it, I can run it locally. And oh, yes. So there is an error in so in my app, I forgot to add the number of how many run to make. Third argument. So now I made a change to my app, so I have to repackage the sandbox and rerun the test. So since I did not change the configuration file, but just the tar file, I can rerun the job script without recreating it. If you edit the ini file, though, you'll have to rerun SkeletonKey to make changes to the wrapper. Okay. Here I have a in the file. Just a second. Sorry, could not open the output.
I'm not sure.
So that's yeah, it's been a glitch with the execution that when connecting back to the shared directory with chirp, the output file was, the script was unable to open the output file. I'll be looking later into that. Let's see the next example. Now I'll be writing a submit file for Condor. Sorry. Yeah. So now we want to run a job using the. So earlier, when adding the cluster to the system, let's see if it's still here. BOSCO specified to us exactly which line we could have been using to run the job. So in order to submit, if we have only a single cluster, it's easier to submit directly using the grid universe. If you have multiple clusters, you have to use the vanilla universe. So in this case, I have only one cluster, so I will use the universe grid. And as a resource, the line suggested by BOSCO when I added the cluster. So if you have multiple clusters, or if you use the universe grid, BOSCO will work anyway, but it will use the campus factory to send the jobs. So that's another piece, and that usually helps if you have more cluster, but if you are in a computer with a firewall, and that might cause problem because the campus factory requires the cluster and the worker nodes where the Glidin are running to connect back to your BOSCO submit host. So my suggestion in general, it's if you have a single cluster, just use the universe grid and specify the grid resource. If you have multiple cluster, then use the vanilla universe. And make sure that your BOSCO submit host is not blocked by a file. So here I specify the job script, and I will pass the output file, and I want Condor to return the standard output, the standard error from the script. And I'll be submitting 5 of these jobs. So now I'll already in my directory. And now instead of, sorry, in the script I have to update, instead of copying the file remotely and running it, you can use BOSCO to submit from here. So use the regular command submit. And these jobs have been submitted to the counter queue. Once they reach the remote queue, they will unpack the sandbox, downloading it from my public HTML directory, and they will run the R script to do the processing and return the output via CVMFS, via parrot and chirp. So they will access R via CVMFS and return the output via parrot and chirp. Now the cluster was more empty in the morning at the moment. Seems to be busy. So I don't know if I'll be able to see the output. Any question in the meantime? Oh, sorry, I didn't see the. So for me, chirp is the program that's exporting the local directory, and parrot is the program that's used in the job to access the directory exported via chirp or via CVMFS. And Scott printed the path for R. So the directory exists, but I think there is a problem with the executable. It's returning an error. So I might have been compiling the wrong way. Okay, for the proxy, we'll make it available, maybe temporary for the. Ideally, the people should use an HTTP proxy that they have on campus. On the tutorial, I added also instruction to install the OSG one. So in the instruction here at the beginning, I point to the OSG instruction to install the squid proxy via RPM. Save in the meantime the jobs completed, but they are still idle. I'm sorry about it. Thank you. Is there any other question? Okay, so Dave is suggesting I might add it to the tutorial or not. That in CVFS you can set the proxy to be direct, but this would have been to be set probably in the server, so we don't want that. There is a risk to overload the CVFS server. We could have in OSG might be publicly available proxy that allows incoming data only from the CVMFS server. That could be probably a better solution than setting to direct the access to the server directly. So to answer to Mia, I don't know if anyone is regularly accessing it this way. I think some of the jobs that are coming from the GloVio are accessing this way. We had user in UC3 using the one installed in the UC3 CVMFS and running job all in UC3. So a limited number of people, there are, I don't know how many. Okay, a correction about Glow, that's actually downloading the tarball for R and installing it in the application. The jobs at UC3 have been running, accessing it from CVFS. I will definitely make some more tests about the installation that currently is in OASIS and make it and advertise it so that it can be publicly available. So the idea from this demo came basically about mixing together the demos done by Derek first, 4 weeks ago, and Suchandra 2 weeks ago. Derek was demonstrated the installation of BOSCO and use of BOSCO to send a simple job, and Suchandra the use of SkeletonKey. It is proper that simplifies the use of parrot and chirp to access data. And putting them together, we can use a BOSCO job to run